Now, the next thing we're going to talk about is intercellular junctions. Remember that inter means between. So these are literally junctions between cells, junctions that hold cells together. So desmosomes are the most common forms of junctions, and we'll see these in all epithelial tissues and throughout organs as well. Desmosomes are made up of protein fibers that are produced by two cells next to each other, and those protein fibers extend through the plasma membrane of each cell and then connect to the cell next door. So the cells then are bound to each other by this physical connection, this little group of protein fibers. Desmosomes are really good, even though each individually is not particularly strong. All of the desmosomes between cells together resist what we call shear forces or lateral forces. So think of these being in your skin, and if you rub your hand across your skin, the cells don't come apart from each other. So that's because these desmosomes are resisting those forces moving side to side across the surface of the skin. Now, each desmosome itself is not particularly strong. Together, they're very strong. They also don't prevent anything from passing between two cells. So if you look at this intercellular space right here between these two cells, the desmosome is just like a button or a snap. Imagine it as a snap between two cells. Things can still go around the snap, right? It could go behind or in front of the snap. So just like you can stick your fingers between two buttons on a shirt, desmosomes do not prevent things from moving through what we call the intercellular pathway. When we need to close off that pathway, we use a different type of junction that we'll come to in a moment. Now, the other thing you'll notice is this thing down here that kind of looks like half a desmosome. Guess what? It's half a desmosome. It's called a hemidesmosome. Hemi means half. So a hemidesmosome, it's protein fibers made by the cell that extends out of the cell and into the basement membrane. And so it's hemidesmosomes that connect the cell to the basement membrane. So think of these epithelial cells. They're all producing the proteins to make hemidesmosomes. And in their lateral sides, those hemidesmosomes join together with a hemidesmosome from the neighboring cell to create a desmosome. On the basal side, the hemidesmosome connects to the basement membrane, which remember isn't cellular, so it's not going to make its own protein fibers. So the cell connects to the basement membrane. Okay, so those are, and again, this is just like a little snap, just like the desmosome, okay? It's just the one side of the desmosome, okay? So these are going to hold everything together, but they're not going to prevent things moving between cells. What we use to prevent things moving between cells are two types of junctions, tight junctions and adherens junctions. So here's a whole row of epithelial cells, and you can see here's a little cutout, zoom in on an enlargement of this portion. We've got tight junctions superficially, and then deep to those we have these adherens junctions, okay? And together, these are going to hold these two cells together. And you can see, if you look very carefully, all the way around here, these tight and adherens junctions go all the way around the cells. So whereas the desmosomes are like snaps, tight junctions and adherens junctions are like the seal on a Ziploc bag. So in order for something to get from the apical surface of the epithelial cell to the basal surface of the epithelial cell, it has to go through the cell. And in that way, the epithelium is going to be able to control what goes past the epithelium because, of course, the cell controls what moves through it. So we see these in places where it's really, really important that only certain materials pass across the epithelium. So in the lining of the intestines, you want nutrients to go through into the bloodstream, but you don't want waste materials or possible pathogens to go through. So these tight junctions prevent any of those materials from sneaking between the cells. We also see these inside the tubules of the kidneys, which are the filters that remove products from the bloodstream so that you can get rid of them. It's really important that the right products get out and that necessary things don't get out. So these tight and adherence junctions are going to be really important there. So think of the tight junctions. They're nice and tight, but they're like the cheap Ziploc bags, right? Like the knockoff Ziploc bags, like they work, but not as well. The adherence junctions are like those super strong, like freezer Ziploc bags with like the triple lock thing, okay? So between the two of them, super strong junction. Nothing is getting past these. Now, one other type of intercellular junction is found in very few places. The most important place we find it is in cardiac muscle tissue, between cardiac muscle cells. And this is called a gap junction. It's literally a channel connecting the cytoplasm of two cells. So here's one cell, here's another cell, and there's a group of proteins that make this gap junction. The importance of this is that, think about your heart. When one cell contracts, the cell next to it needs to contract at the same time. So the signal, the electrical signal that makes one cell contract, needs to tell the cell next to it to contract as well. So that signal has to pass immediately from one place to the next. So the electrical signal in this cell, it doesn't have to diffuse across a membrane if it can just go through this gap junction. So just like if you stick a knife in a light socket, okay, that signal is going to go straight from the light socket through the knife to you. If somebody then grabs you, they're going to feel that electricity as well. It's going to go straight into them as well without pausing. So that's essentially creating a gap junction between you. So these gap junctions between the cell enable that really, really fast movement of that signal. All right, so those are our intercellular junctions. Up next, we're going to learn how to distinguish epithelial tissues.